I'm Anil Kumar, and now let us begin to understand how to solve trigonometric identities. So I have taken Pythagorean identities which are well established. You can always use them to prove trigonometric identities, but in this video we'll kind of prove these identities themselves. So first one here is tan square theta plus 1 equals to secant square theta. The second one is cotangent square theta plus 1 is cosecant square theta. One which you already know and which we might use here is sine square theta plus cos square theta equals to 1, right? So that is another Pythagorean identity which we know about, which we might use here, right? So to prove identities, we have to start from one side. So let us start from the left side, which is tan square theta plus 1. Tan should be written as the ratio of sine and cosine. So we can write this as sine square theta over cos square theta plus 1. Now we can take cos square theta as a common denominator. So that is how our left side is going to be. We have cos square theta. So we get sine square theta plus cos square theta, right? Now sine square theta plus cos square theta is also Pythagorean identity, which is 1. So we can write this as 1 over cos square theta. Now 1 over cos square theta is secant square theta, right? So once we prove that the left side equals to right side, we say that we have proven the identity. So that is how we prove identities, correct? So that's the way. So let's do the second one, follow the same process. Cotangent will be cos over sine, right? So it is cos square theta over sine square theta. We have started with the left side, which is equals to this plus 1. Now we'll take the common denominator, which is sine square theta. And we can write this as cos square theta plus sine square theta. You know the numerator is 1 and the denominator is sine square theta. 1 over sine square theta is cosecant square theta, which is the right side. So we have proven that the left side is equals to right side. So that is how you can prove these identities. Elsewhere, we have also proven that these identities could be proved within a right triangle, right? So if I have a triangle with angle theta here and the sides are, let us say, x, y and r, then we know x square plus y square equals to r square. If we divide this by, let us say, x square, then we can get one of these identities. If we divide by y square, we get the other, right? So that is another way of proving. So what is tan? Tan is y over x. So to get this identity, what we can do here is, let me show you here. So we have x square plus y square equals to r square. We are taking help of the right triangle to prove this identity, right? That is not this, but in addition to that. So if I divide by y square, what do I get? X over y is what? X over y is cotangent, right? So if I divide by y square, I get cot square. So actually, so it is cot square theta plus 1 equals to r over y, which is cosecant square theta. So we proved this one. If I divide them by x square, then what do you get? Then you get 1 plus tan square theta equals to secant square theta. Well, so I'll connect you with this proof also, but that is how we generally prove all identities, including the one which we have taken, right? But the solution for this particular question was the one which we gave initially. I hope that helps. Thank you and all the best.